Hello, hello, hello! Welcome back to another live stream. I'm glad that a lot of you found that helpful, what I did last time, going through it, demonstrating the multiple pass technique. And I just looked at the calendar and I realized the ESAT is like next week, which is utterly insane. So I thought I'd like up the frequency of the streaming, make sure that you guys have enough examples of me putting the technique into practice to make sure you guys know exactly what you're doing on your end. I know someone recommended I do the 2020, but I just had a look at it and it's something I've done with so many of you so recently that there's no way it could be like a fresh organic live solve where you actually see me challenged in any way. So I might put that up just so you see how it could work and I could explain it. But I think I'd rather do one where I think like I don't know the answers as much, just so you see me do it in the same state that you will be doing it next week. So I have the 2021 instead. I think I'm just going to go through that. And I'm also going to make sure that when I'm sharing the screen, you can actually see my working at the bottom, because I realized my face was in the bottom right, covering up my work sometimes. So I'll just make sure I get that done. And without too much further ado, I say we just get into it. So let me start sharing my screen. Get myself out of the way. Okay, let me draw, like, how much can you see? So you can go down to that line. Okay, so that's good for me to know. In the meantime, those are answers. I don't want answers. Let me scroll down. I'm going to do what I did last time. I'm going to start on the math 1. 20 questions of that means half an hour on the clock. I looked at a way of getting like a timer, but I think in a different screen, like it would take, I'm going to have to find some way of doing that. So in the meantime, you're going to have to trust me on my timing, but I'm going to do much the same that I did last time. Just sort of go through a live solve, take my splits. And this time I'm even going to try and get the answer and then select the letter that corresponds with that answer. Can you imagine? Right. So let's see how this goes. Ready and go. Oh, this one I know. So this we can do with graphing. So question 20. In minus 360 to 360, I'm going to graph. So it goes up, and then that's 180, and that's 360. Same in the other direction. And that's going to be minus 270. Okay. Now, the graph of 100x is going to be a straight line through the origin. Let's pretend that was a straight line through the origin. It's going to intersect there. Oh, no, that's just so bad. No. Can I draw a straight line on this? Good enough. Okay, so don't waste time. This is silly. Okay, so a straight line will do something like this. So it's going to intersect. No. Okay, stupid. Okay, so it's going to intersect at the origin. It's going to intersect that once. It's going to intersect once up there, and somewhere on down here. So that makes 5, which is F. Okay, split. Moving on. So here, I actually quite like these as well. So 19 m miles long. 1 kilometer is, so 1 kilometer is x miles. So m miles, we have to divide by x to multiply by m, is m over x kilometers. The car uses 1 liter of fuel to travel f kilometers. So I have to multiply by f to get the number of liters. And I have to multiply by p to get the number of pence. And then the number of pounds will be that divided by 100. So F PM over 100x is F. Great. Moving on. No, I hate speed. Next. No, I'll wait until I've got time on that. Okay. vertices of the cuboid is root 77. Similar cuboid is all its lengths, exactly half the original. So this is going to be similar shapes in 3D. So the smaller are 2, 3, and x. And the larger, well, this is if this is a length area volume thing, we're told that all the lengths are exactly half the lengths. So we just know the small to large is a 1:2 ratio. And that's still a distance. So the distance there, so root of 2 squared and 3 squared and x squared, this distance would be root 77 over 2. So that's the distance there, which is root of 77 over 4. So 4 plus 9 plus x squared equals 77 over 4. So 16 and 36 and 4x squared is 77. 4x squared equals, well, that's 52. 52 from that is 25. Right, x squared is 25 over, nope, sorry, I realized you can't see what I'm doing. Let me scroll down. So I'll get used to that. Working this through, yeah, I'm out of time, so I'll move on. So x squared over 4, so x is equal to 5 over 2, which is a. Okay, split. I realize I'm taking time to explain things, which is slowing me down, but still, I'll do my best. And I'll try and remember, okay, not to write where you can't see. So right angle triangles, same hypotenuse length. Same hypotenuse, which means that for 16, sine 45 is y over the hypotenuse. So 1 over root 2 is y over the hypotenuse. And on the other one, sine 60 is equal to x over the hypotenuse. I can never be bothered. 1 to root 3. So sine 60 is root 3 over 2. Is equal to x over h. Y in terms of x. Well, h is equal to root 2y. So that is x over root 2y. And then cross multiplying, we have root 6y over 2 equals x, but I want y as the subject. So y is equal to 2x over root 6, scrolling down so you can see. And that means that it is 2 root 6 over 6, which is root 6 over 3x, which is g. Okay. $15. What's happening here? Red and green sweets only. 9 sweets in total. 2 sweets eaten. Not eating any green sweets. 2 greens. So let's do it in terms of greens. So there's green greens and 9 minus green reds. So the probability of not eating any green sweets, no, okay, let's do it in terms of red then. So if there's R red, so what that means is he eats 2 reds. So that's going to be red over red plus 9 times red minus 1 over r plus 8, because that's the new total on the bottom. So that is going to be equal to 5 over 12, which means that r squared minus r all over r squared plus 17r and 72 is equal to 5 over 12. 12r squared minus 12r is 5r squared, and don't like that. All right, let's just try it. 85r plus 360. So 7r squared minus 97r minus 360 is 0. Ugh. Oh, it's because it's not r plus 9. God damn it. All right, let me try it again. Okay, wasting time. So there are 9 suites, and then there are 8 suites. This makes much more sense. All right, r squared minus r over 72 is 5 over 12. Multiply that up, so then it becomes 6, makes that 30. So r squared minus r minus 30 is 0. R plus 6. No, r minus 6, r plus 5. So r equals 6. Green is 3. So 2 green suites is 3 over 9 times 2 over 8. Cancels, cancels, 1, 3. Cancels, cancels, 1, 4 is 1/12, which is B. I'll have lost time on that. Let's try and make that up. Okay, circle theorems. I like this. Okay, so that's 180. Sorry, that's 140. So PR is 7, radius of the circle. Ugh. Well, what we know, circle, rough sketch, if that's 140, angle to the center is double the angle to the circumference. So long way around, that's 280, which means that in there is 80 to make it up to 360. That is 7, that is R, that is R. But then I can split it down the middle and make a right triangle, which has 40 and 3.5. And I'm instructed by the 40s and the 80s everywhere. So I think that is how they want to do it. So sine 40 is 3.5 over r. So r is equal to 3.5 over sine 40, which is E. Okay. Zoom in a bit. So why is that? What's y cubed? Ugh. Okay, no, this is fine because I know what those are for my special triangle. So for 13, special triangle, which comes up, they love it so much. So sine 60 is root 3 over 2 minus 1 all over cos 60, which is a half. So that doubles up and you get root 3 minus 2, and that's all cubed. So I'm going to use my binomial expansion and say that's going to be that cubed, which is 3 root 3, minus 3 times that squared, sorry, plus 3 times that squared times that, plus 3 times that and that squared, and then plus that cubed. So 3 root 3 minus 18 plus 12 root 3 minus 8 is 15 root 3 minus 26, which is F. Okay. 12. Cell storage containers. We've got, okay, so orders 2 containers at random from those available. What's the probability the 2 containers will have a combined capacity of exactly 10? Well, how can I do that? I can order a 2 and an 8. So the first one could be 2, the second one can be 8. The first one can be 3, the second one could be 7. The first one could be 7, the second one could be 3. The first one could be 8, the second one could be 2. So that's going to be, and there's number of variables adding up to 10. So there's 2 out of 10. And then 1 out of the 9 remaining. There's 3 out of 10. And then 4 out of the 9 remaining. 4 out of 10 times 3 out of the 9 remaining. 1 out of 10 times 2 out of the 9 remaining. So 2 out of 90, 12, 12. So it's 2, 12, 12, 2. 14 times 2 is 28 over 90, which is 14 over 45, which is D. And I'm actually writing down, I hope, the correct letter for the number. Okay. So moving on, 11. Curve with that equation meets that at 2 points. So it means there's going to be just 2 solutions to the, when I equate them, I'm going to form a quadratic with 2 solutions. Let's find out. Do you know what I'm in? I'm in now, so I may as well continue. So that's going to be x squared minus 4x and 5 is 2x plus c. So x squared minus 6x plus 5 minus c is 0. I know this has 2 solutions. Oh, wait, no, at 2 points which have x coordinates p and q. Right, so they love this. So again, actually I'll solve this. So x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, which is going to be 3 plus or minus square root. I'm going to take a 4 out of root 4 out to make 2 to cancel with that. So that's going to be 4 out of there is 9 minus 5 minus c. So it's 3 plus or minus root of 4 plus c. And that plus or minus, so double the square root 4 plus c is the difference between the two roots, which is equal to 8. So root of 4 plus c is equal to 4. 4 plus c is equal to 16. And c is equal to 12, which is f. I'm definitely taking too long explaining things. I might go through that in a bit more detail. That did come up last time, though, so hopefully that makes sense. So ratio of Pat's to Alex. Okay, so ratios are fine. So Pat to Alex is 5 to 2. So there are 7 parts in 63 pounds. So each part is worth 9 pounds. So we're just going to write that down, 9 pounds per part. So it's 45 to 18, just in case I need to know that. They each spend an equal amount on sweets. And then it becomes, so 45 minus x, and this is what it becomes, and that is in the ratio of 3 to 1, which means this is 3 times that. So 45 minus x is 3 times 18 minus x. They spend an equal amount, so it doesn't matter who spent. Okay, so we're just solving for x. So that is 54 minus 3x. So 2x is 9, and x is £4.50, which is E. Okay, let's keep it going. I feel like I'm not as urgent as I should be, but it's because I'm early and sorry, I'm tired. It's early. So, right angle Q, point on R such that SRRQ is in 1, 2. I'm going to have to draw this out. Okay, so this is in 9. So that is 1 to 3. So that's 4. That's 8. That's 8. If that's a right angle, this looks like okay, so that's gonna 1, 2. This is a scaled up 1, 2 root 3. So this is gonna be total 4 root 3. So that's gonna be root 3. That's gonna be 3 root 3 because it's split into 1 to 3 ratio. So that gets a quarter of the 4 root 3. And then what is length of PQ? Right, this I'm actually gonna have to Pythag. So that's PQ is the root of 64 minus 27 is root 49. Nope. 37, which is D. Okay. So yeah, spotting that they love that triangle so much. It comes up time and time again. So here I do remember this. I've done it stupidly in the past, but the trick here is 1, 4, 9, 16. So 196 is the end of the 14th row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 196. Oop, no. So then what's going to happen is the number directly below that is going to be that plus 14. Wait, 1, 2, 3, 4, 5, 6. Yeah, it's the end of the 14th. No. So it's not. So it's 2 squared. So it is the end of the 14th row, but the 14th row does not contain 14 things. Each row contains 2n minus 1 things. So 2n minus 1, where n is 14. So that's going to contain 27. That's the 27th item. So the one directly below that is going to be 27 more after that, which is going to be 2, 2, 3, which is F. May have got that wrong. We'll see. I think in the real thing, I would have focused a bit better. I think I'm half in, half out with trying to explain things on the go. So price of a P is reduced 10%. New prices, okay. So that's P, it goes to 9/10 P, and then that goes to 11 tenths times the 9 tenths p. So it's 0.99 of the original. Price of Q is increased, so Q goes to 11 over 10Q, which goes to 11 over 10, and reduce it by 10%. So it's also 0.99Q. So they're both lower than the original, which is A. And that's question 7. Cool. Right, moving on. Given that that's true, this looks like it's going to be fun. What's the value of x? I'm noticing 2s and 3s. We can obviously, let's eliminate. So 2 times 8 to the x, by adding these equations, those cancel, equals 26 over 30. No, why can't I add those up? That's 18. 18 out of 36, which is a half. Now this is 2 to the 3x, so 2 times that. So 2 to the 3x plus 1 equals 2 to the minus 1, which means that 3x plus 1 equals minus 1. Move that over for minus 2, and x is minus 2/3, which is E. Yep. I should have taken a note of what I skipped. It's all right, I'll come back. 5, and I'll look at that, what I didn't like as well. So already planning ahead for my second pass. Diameter D, height Y. Diameter Y, height D. Positive difference between the total surface areas. So surface area is going to be 2 pi r squared plus 2 pi rh. So for P, that means it's 2 pi x over 2 squared plus 2 pi x over 2y, which is pi x squared, that's over 4, but times 2, so over 2. The 2's cancel, plus pi x y. And for Q, that's going to be 2 pi y over 2 squared. Well, they just swap round. So 2 pi y over 2x. So that's going to be pi y squared over 2 plus pi xy. So those are the two surface areas. So it's going to be that minus that. Those will cancel, and you're going to get pi over 2 into x squared minus y squared, which is C. Okay. 4. Tangent. Okay, let me draw this out. Circle. Tangent that touches the circle at, well, if it touches it 4, 3, that's a 3, 4, 5 triangle. So the radius is 5. So I know that x squared plus y squared is 25 is the equation of that. Tangent that touches there. So well, the gradient of this, so if that's 3 and that's 4, the gradient is 3/4. So the gradient of this is going to be minus 4 over 3, and it's going to go through the 0.34. So y minus 3 is minus 4/3 x minus 4. So 3y minus 9 is minus 4x plus 16. So 4x plus 3y equals 25, which is A. 3y plus 4x is 25 is A. Good. Not going to try and make that mistake today. Take a split. So 3. I've still got plenty of time, so I've got 8.5 minutes. Checking the clock, making sure I'm good and ready. Q is the subject. All right, this is going to be fine. So 3 over Q is equal to 4 over R minus P over 2, which is 8 minus PR over 2R. I'm going to flip them both over. So Q over 3 is 2R over 8 minus PR. And Q is equal to 6R over 8 minus PR. 6R over 8 minus PR is D. Taking the time to make sure I get that right. Okay. Simplification of that again. So we're into the simple part. So for 2, this is going to be 2 minus, let's factorize, x into 1 plus 3x all over. Bleh. So that looks like it's going to be a 3 and a 4 situation because it's going to be minus 3x plus 4x. And those terms cancel. So then it becomes 8x minus 2 minus x all over 4x minus 1. So it's 7x minus 2 over 4x minus 1. 7x minus 2 over 4x minus 1 is B, taking the time to lock that in, taking a split. And then moving up to 1. So power laws, classic. So it's going to be 5xy squared times 1 over 125 x minus 6 y minus 3 5x squared y. So those cancel with that to make a 5 on the bottom. We're going to get x cubed, so x to the 3 minus 6, so that's x to the minus 3, y to the 6 over 5, so that's y to the 6 all over 5x cubed. I've done something wrong, clearly. Right, no, sorry, apologies. That should have been a minus 3. So those make y cubed. With the y cubed, those all just cancel down, so you get no y's at all. So it should be 1 over 5x cubed, which is E. Okay, so I've got 6 minutes left. Let me go back and do the one on speed that I hate, but it's fine because I've got time now. 6 minutes is fine. So 400-meter race. Oh, no, I really hate speed. God damn it. All right. 12% faster than Cameron. Sam is running 2% slower than Cameron. We're comparing Alex and Sam, so let's go via Cameron. So the speed of A is 1.12 the speed of C, and this is for 18. We know that the speed of Sam is 0.98 times the speed of C. Let's divide those through to get the speed of A relative to the speed of Sam is 1.12 all over 0.98, which is 112 over 98. Let's divide by 2. So 56 over 49 gives the relative speed there. Yep, we can cancel it. So that's 8 over 7. Okay, when Alex crosses the finish line. So let's get that specific time. So that happens. So distance, whatever. So distance equals speed A times the time we're looking for. So the time is 400 over VA. That is the specific time. Where is Sam? How far? So Sam has traveled the distance of VS times the time. So VS over VA is 7/8 of the 400. So that and that makes 50. So they've traveled 350 meters. So they are 50 meters from the finish line, which is F. Boom. Okay, 4 minutes. I was less certain on... Where was it? It was this. It wasn't that. It was... I'm not offline. What are you talking about? Which was the one I wasn't certain on? Oh, this one, 8. All right, let me go back and check that one. In fact, let me just redo it just to make sure. So 1, 4, 9, 16. So the final one in each row. So that is definitely n equals 14. The final term will be 196. In each row, how many items are there? 2n minus 1. Because the common difference is 2, give me my 2n. And it's minus 1 from each to get the right. Okay. So 2n minus 1. 28 minus 1. So there are 27 terms in that row. So in N14, there are 27 terms, the final of which is 196. So then I start from 197, which is the first of the next 27 terms. So 26 later from that is going to be 223. So I think that was correct. I think that was F. And I'm happy to lock that in. and the real thing I might have had some time to check. Let's just sort of see how that is. Because I think that'll honestly just be really boring for you. So let me scroll back to the top. Let's see how that went. That one felt a lot better than the other one. 2022 math one was just awful. All right, let's go through. I'll first just do the scores, and then I'll go for the split times. So 20F, let me zoom in so you can see. So 20F is correct. 19. Oh, I got that wrong. Maybe I should have checked. How did I get that one wrong? I really like those questions. Hold on a minute. Oh, that's devastating. Why am I not focused? Hold on. Oh, 1 liter is F kilometers. So it's 1 over F liters for 1 kilometer. I just didn't. I went through too quickly on that one. Do you know what that was? That was an execution error because my brain thought that was going to be too easy. I've looked at questions like that in the past. I know how to do these. You saw how confident I was at the start. And it's exactly that. It's when you think you're safe, it's when your brain kind of skips steps and goes, oh, this is fine. And then you introduce little execution errors like that. That's so frustrating because that's beneath me, that mistake. All right, let me walk through how it should have been done. So yeah, but because I like that system of just clearly saying 1 kilometer is that. What I should also have done, that is silly of me, is to also have said 1 liter equals F kilometers. So 1 over F liters equals 1 kilometer, which is why I should have multiplied that through and got M over Fx, then multiplied it by P for pence, and then divided by 100. That's bad. But okay, so what do I take away from that? Honestly, just lay it out. Just don't skip steps. Just do it. Like I was just better than that. 17A. Good. 16G. 15B. 14E. 13F. 12D. 11F. 10E. 9D. 8F. Good, I did get that. 7A, 6E, 5C, 4A, 3D, 2B, 1E. So 19 out of 20 should have been 20 out of 20, comfortably in time. Okay, so this, honestly, if I'm making an execution error that bad, it tells me I'm actually not focused, and I really need to lock in when it comes to the physics and the math too. Right, let's go through the splits and see if my technique worked well. So going through, my splits were 110, 105, then there was an 8-second skip. This took me a little bit too long. This took me 143, but it might have been because of the explanation. Okay, so then we have 124, which is good. This did take far too long, but that's because I made the mistake. But that's fine because I corrected it quite quickly and then filled up the time elsewhere. Then it was 112, 107, 115, 105, 116, 121, 54, 52, 122, 124, 42 seconds. Nice. 43 seconds, 105, and then 151, but that's again because I made a mistake. And then I went back and did that in 117. Was there anything I needed to explain further? I think all my explanations are pretty good for as I was going. I think, yeah, this one, I think you guys know from last time how that goes, but I'll just do that in a bit more detail, just in case that was confusing in any way. So here, I'll get my little Pemba tool. Where'd you go? Ah, there you are. So here, So the solutions are, so if x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, well, this in the middle is going to be your minus b over 2a, and then it's going to be the square root over 2 in both directions, or over 2a in both directions. So the distance between them is obviously going to be twice that. So that's why I said 2 root of the discriminant, and I'd simplified it by that point. So over 2a is equal to the 8. So in this case, I simplified it already. So then the difference between the square roots, so the roots, root in the plus direction, root in the minus direction, so twice that root, so twice the root 4 plus c was going to equal that 8. Hold on, let me just, nope, let me just get rid of that. Okay, so, nope. Was there anything else that needed explaining, just in case? So this one was just graphing, making sure you don't neglect the origin. This, again, just focus. All right, this was just simple, similar shapes in 3D. So you have your length ratio, your area ratio, your volume ratio. Getting the question so you can see. So I knew it was just the length ratio was a half, which means that the root 77 was going to be just a half as well. So root 77 over 2. And then in Pythagoras, it's root of x squared plus y squared plus z squared when you're doing it in 3D. And then from there, I think it was self-explanatory. This, again, was self-explanatory. This I got after time. This one, just making sure people are aware. Angle at the center is double the angle at the circumference. That works on both sides. So what I mean by that is, getting that back. So that 140 is half of, so the angle to the center is 280. So this 80, if I'd drawn an angle like that, angle to the center is double the angle to the circumference. And that also works because we know the opposite angles in a cyclic quadrilateral add to 180 degrees. So that's what I used to get around it quickly. And then from there, recognizing that if that is an isosceles triangle, then by splitting it down the middle, it's going to bisect the angle, which is a special case for isosceles triangles. And it's also going to perpendicularly bisect that 7 to make that 3.5 there. So just exploiting that in isosceles triangles and with the circle theorems. Cool. Anything else need explaining? No, that was fine. But just getting good at doing your binomial expansion. Here, yeah, making sure you consider the orders as well as just the combinations. So a lot of people might have made the mistake of going, oh, 2 and 8 and 3 and 7, and getting C instead of D. I think those were my answers. What was 12? Yeah. So this one I've explained. That one I've explained. This one, just get real good at spotting your 1, 2, root 3 triangle. That 30, 60, 90 comes up everywhere. And so I went, oh, I know that ratio, 2, 1, that's going to be then the root 3. So the 4 root 3 came out of that quite quickly. And then that splits that into a 1 to 3 ratio, which means that's a quarter of the 4 root 3, which is your root 3. Then my 3 root 3, and then I just did Pythagoras. So that's fine. This I've talked about ad infinitum. This I explained quite well. This is just, yeah, simultaneous equations. This, I think, was explained. This was explained. I think I might want to go through that in a bit more detail just in case. So here, I drew it out. I knew that it went 3 up for going 4 across, which means that the gradient is 3/4. Perpendicular, tangents and radius is perpendicular. So I take the perpendicular gradient, make that 4 minus 4 over 3. And then always use, so the equation of the circle was actually kind of redundant. Oh, no. But then just using the equation of a line, y minus y1 equals mx minus x1. Put that through, rearrange, get an answer, done. This, I think, was self-explanatory, as was this, as was this. Obviously, like you may not have spotted how to factorize that as quickly as I did, but then you can just go through whichever method is your preferred. So an alternative for factorizing that might have been getting your target number of 12 times -1, so minus 12. I know I want factors that make plus x, so that's going to be plus 4x and minus 3x. You have two options at that point. You either say 12x squared plus 4x minus 3x minus 1, factorize in pairs. So I take a 4x out of that to make 3x plus 1, factorize a minus 1 out of that to make a 3x plus 1. And then the 3x plus 1 is the same in both. So I can factorize that whole thing out, make it 4x minus 1 and 3x plus 1. Or a preferred method I've taken from the IB that I think is a little bit faster. Very similar idea. I've got my plus 4, my minus 3, but instead I say 12x plus 4, 12x minus 3, and divide it all by 12. And then you can cancel in pairs. So this is going to cancel a 4 to make it 3x plus 1. And this is going to cancel the remaining 3 to make it 4x minus 1. And you get the same thing. So once you get your plus 4 and your minus 3, you can factor that into 12x in both and then divide by 12. And that works for whatever a is as well. So just making sure you have those techniques, just in case you don't. Then onto here. Yeah, this is just GCSE stuff. All right, so I think that's all that needs to be said about the Math 1. I'm now going to move on to the Math 2, which as last time, I'm going to do it from the ENGAA. Hold on, let me zoom in, just make sure I'm writing at the same level. Okay, so this is going to be a 15-minute run going through. And I'm going to not there because that's physics. So the math ones are going to be the odd ones. Yeah, here we go. Oh, I remember this one from the past. This is such a good question. So here, started the clock. So 39. That's a rectangle. That is on the x-axis. Q and R lie on the line x equals 15. S lies on the curve y equals root x. What is the maximum possible area of the rectangle? Actually, no, I am going to come back to that. That was a late skip, but oops. Oh, this. Okay. This I think I can do right now. So calling that 37. So that is going to be 3 into root 27 minus root 21 all over. Now that on the bottom is going to be difference of two squares. 27 minus 21 is 6. That is going to be 3 into root 24 minus root 18 over 6 plus blah, 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 blah. That's going to go all the way down. So it's going to be half of all of those. So it's going to be a half of, and it's going to be half from all of them. It's going to be root 27 minus root 21 plus root 24 minus root 18 plus root 21 minus root 15. And you'll notice these are all going to cancel down. And then what's it going to be right at the end? It's going to be plus root 12 minus root 9 minus root 6, which will all have canceled. And then it's going to be plus root 9 minus root 3. So I think you're only going to be left with the half. You're going to be left with root 27 minus root 3, which is half of 3 root 3 minus root 3, which is 2 root 3, which is just root 3, which is D. Locking that in. That's crazy. I'll explain that more later. So come on, find it. Come on. All right. So 35. How many distinct points do the following two curves meet? All right, let me factorize them both. So y, nope. Cross it out. Right, y is x minus 4. That is x minus 4x plus 2. So it's x minus 4 squared x plus 2. And this guy, the second one, is y is the negative of x squared minus 8x plus 16, which is the negative of x minus 4 squared. All right, so let's set them equal to each other because they meet. So x minus 4 squared, x plus 2 is equal to the negative of x minus 4 squared. Move that over, you get x minus 4 squared, x plus 2 plus x minus 4 squared equals 0. And I can take the x minus 4 squared out of that, and I'm left with x plus 3 equals 0, leaving me with two solutions, x equals 4 and x equals minus 3, which is C. Okay. Oh, classic. So 33, first term A common ratio R, sum to infinity. So A over 1 minus R equals 8 over 5. 5A equals 8 minus 8R, just so I know. The sum to infinity of the even numbered terms is 3/5. All right, let's write those out. So that the even number terms are going to be AR cubed, AR5, etc. And the sum of those is 3/5. So the first term is AR over 1 minus the common difference there is R squared. And that is going to, the sum of that, A over 1 minus, is equal to 3/5. But that's AR over 1 minus R, 1 plus R is 3/5. And I know that A over 1 minus R is equal to 8 over 5. So scrolling down a little bit, so that's 8 over 5 times R over 1 plus R is equal to 3 over 5. The 5s cancel. So 8R equals 3 plus 3R. So 5R is 3 and R is 3/5. And then again, we know that then coming back over here, we know A over 1 minus R is 2/5 is equal to 8/5. So A is equal to 8/5 times 2/5, which is 16 over 25. And 16 over 25 plus R, which is multiplying that by 5, 15 over 25 is 31 over 25, which is B. A little bit long on that. Which of these is the largest in value? Oh, I've seen this question last year. I haven't seen it this year, but that's how memorable it is. Okay, so all angles are radians. So let me just draw the graphs. So cos is doing something like this. Sine is doing something like this, where that's pi, and that's pi over 2. Now we approximate pi as, okay, so, well, first of all, let's cancel some out. So clearly cos is getting smaller. So cos 0.5 is the biggest of those, and these are getting bigger. So sine 1 is the biggest because, again, this is pi over 2, which is approximately 1.5. So we haven't reached the maximum yet. And pi over 2, again, is approximately 1.5, so we haven't reached the minimum yet. So it's either between A or F. Now, from this point, cos of 0.5, sine of 1. Cos of 0.5 is approximately equal to pi over 6. Because 0.5 is approximately equal to pi over 6. Okay, so pi is actually bigger than 3, so this is actually bigger than 0.5, so I've moved on a little bit further from that. So it's going to be a little bit less than cos of pi over 6. Apologies, let me scroll down so you can see. And we're going to do a similar thing on sine. So sine of 1 is going to be approximately equal to sine of pi over 3. But again, this is slightly bigger than pi over 3. So sine of 1 is going to be bigger than sine of pi over 3. But from the special triangle, 1, 2, root 3, sine of pi over 3 is root 3 over 2. Cos of pi over 6 is root 3 over 2. So this is less than root 3 over 2. This is bigger than root 3 over 2. Sign 1 is the biggest, and that's F. That took way too long for a first pass. Really should have left that. Was getting overconfident. But it's all right. We're going to make this up on 29. So 29, mean of that is going to be log 27 plus log 64 plus log 216 all over 3. That is 3 cubed. That is 4 cubed. And that is 6 cubed. So that becomes 3 log 3 plus 3 log 4 plus 3 log 6 all over 3. The 3's obviously cancel, and you get log of log 3, log 4, log 6. And you combine them, multiply it all together. 12 times 6 is 72. So the answer is E. Okay, so this is a circle. So 27. So we got a circle of radius 2. And we have x equals 1. So that's 2, that's 1, that's 2. Would you look at that? 1, 2, root 3. So the area of the smaller segment is this full area. Wait, into the line, so into 2 segments. So we want the area, we want this area. So that's going to be sector minus triangle. So the sector, well, that's 60. So the sector is going to be, and that's 60. So it's a third of the total square. So a third of pi, and radius is a third of 4 pi. So that's the area. And you subtract from that this triangle. And I know the height of that is 2 root 3. And that was so, oh, brilliant. So a half times the base of 2 root 3 times the height of 1. Those cancel, so it's minus root 3. So it's 4/3 pi minus root 3, which is h. Brilliant question. I'll come back for that. How many real distinct solutions are there for this? 25. So that means that x squared plus 4x plus 3 is equal to plus or minus 1. So I'm going to write those out separately, which means that x squared plus 4x plus 2 equals 0, or x squared plus 4x plus 4 is 0. Well, this is just x plus 2 squared. B squared minus 4ac. Yep, this has, so b squared minus 4ac is 8, which is bigger than 0. So that's 2 solutions. And so there's 3 solutions in total, which is D. And yet more series. Let's go. So 23. Particular arithmetic series. First term, A, comma difference D. Sum of the first k terms is sk. First k terms. So that. Okay, so the sum to n plus 1 minus the sum to n minus 1 is just going to be knocking off everything except the n term and the n plus 1 term. So that's going to be a plus n minus 1d and a plus nd. So it's 2a plus 2n minus 1d, which is g. Okay. And here, given that that is a thing, differentiate when x equals a half. Okay, so 21. What do I want to do first? Let's square it out. Square the first, square the last, and twice the middle too. I'm just going to do this fully. Those obviously cancel. So it becomes 4x minus 2 plus a quarter x to the minus 1. Great. Let's differentiate. We get 4 minus a quarter x minus 2. And when x is equal to a half, that's going to be equal to 4 minus a quarter into... So the minus is going to flip that up to 2, square that up to 4. Those cancels. 1 equals 3, which is C. Okay, so now I've got another 2 minutes to go back because I think I skipped one. Yeah, I skipped the very first one. This one. Okay, so I've got 2 minutes left. Rectangle. Okay, so let's see if I can get there. That's x is 15. So if that's x, if that is x0, this is x and root x, and this is 15 and root x, and the height there is root x, and that is 15 minus x. So the area of the rectangle, which you can't see now, is going to be given by 15 minus x times root x, which is 15x to the half minus x to the 3 over 2. We're going to differentiate and get 15 over 2x to the minus a quarter minus 3 over 2x to the half is 0. So I'm going to multiply by root x. 15 over 2 minus 3 over 2x is 0. X is equal to 5. Maximum possible area. So that would be 10. That would be root 5. 10 root 5 is B. Done with 40 seconds spare. Okay. So I didn't bother explaining it to you guys. I was like, no, I'm getting this done in time. I want my points. But all right, let me do the breakdown now, see how that went. So timing was like, okay, let's have a look. So 37 H. Why am I getting things wrong? Oh, God. Okay, let me go through this again. What did I... I mean, I definitely got the right idea. Things are definitely going to cancel. So what did I miss? What did I skip? So that is definitely 3 into root 27 minus root 21 all over the difference of 2 squared, which is a 6. That's going to be 3 into root 24 minus root 18, again, all over 6. So they're definitely all going to be over a half. Because that's the difference of 2 squares. Because on the bottom, you would get root 27 plus root 21 times root 27 minus root 21, which is 27, and the minus 21, which is 6. So and that's going to be the same across the board. So these are all going to be 6 on the bottom. So it's going to be a half into all of that business. And it is definitely going to be root 27. I mean, I wonder if this is the case as last time, like whether I got the right answer, because I really back my answer. I really back 27 being D, unless I've looked up the wrong year. Let me just see if the others are all. Maybe 21. 35 was C, 33 was B, 31, oh, F. Did I get it the wrong way around? So this is not a good run for me if this is the case. So cos. Oh, God, I did get it the wrong way around. I did get it. God damn it, all my logic was correct. Okay. Okay, I'll go through that. So 29E. 27 H, good. 25D, 23G, 21C. I genuinely question whether this was wrong. So I'm just gonna look that up again just in case. I'm gonna find a work solution on that. Because they aren't as forthcoming on the website. So ENGAA 2021 work solutions. So ENGAA 2021. So which one is that? 37. Okay, well, that's not helpful. What are the actual answers? Am I going to find it? So 37. They're not actually telling me what it was. So 37H. Let me just redo it. Okay, so ones I need to go through, certainly 37. Let me just redo this more slowly. So under time conditions, let's see if something went wrong, because I loved that solution. I don't want it to be wrong. Maybe that's part of the problem. All right, let me have a closer look. So rationalize the denominators, look for cancellations. So minus root 21 plus root 20. Maybe it was just in the detail right at the end. So minus root 18 plus root 21 minus root 15. Let's just go all the way down. 18, 12, 15, 9, 12, 6, 9, 3. Cancels. Oh, the 24 didn't cancel. That's what I missed. I missed what was going to cancel and what wasn't. So that's the problem. The 24 doesn't cancel. I was over ambitious. Okay, I tried to skip the steps on that. The 18s cancel, the 15s cancel, the 12s cancel, the 9s cancels, but the 6 and the 3 also don't. Okay. The right idea, but I thought the 24 would cancel when it doesn't. So I should have included more terms. So that should have been a half. I actually did get that wrong. So 3 root 3, that is 2 root 6 minus root 6 minus root 3. So yeah, it's root 6. So that leaves you with a half of 2 root 3 plus root 6. So it is root 3 plus a half. Okay, and then what did they do? I suppose you could take a root 3 out. So root 3 over 2 into 2 plus root 2 is a possibility. Oh, no, I just took a root 3 out. So it's a half plus what? So the h. Okay, so that's why it's h. Man, that was disappointing. Okay, so that was just conceptual. That just messed me up how to do that. No shame in that. So 37h. Annoying. I should have got that, though. All right, let me go back to the bottom. This, I think... Okay, so let me explain it in a bit more detail, because I definitely rushed it at the end. Okay, so the logic here, if that is x with a y-coordinate of 0, that is x with a y-coordinate of root x, so the height of the triangle is root x. This would become 15 with root x, and this is 15, 0. So the length of that is 15 minus x. So the area, you multiply them together, 15x to the half minus x to the 3 over 2 is the area, and you differentiate it and set it to 0. So I differentiated it to 15 over 2x to the minus a half minus 3 over 2x to the half. And then I skipped steps that you might have missed. So x to the minus a half minus 3 over 2 x to the half equals 0. What I noticed is you can take an x to the minus a half out, which is going to get you 15 over 2 minus 3 over 2x. Or alternatively, I multiply by root x, which is going to cancel that out, and then root x times root x is just x. So this bracket has to equal 0, which happens when 15 minus 3x is 0, so x is equal to 5. When I plug x equals 5 into here. I didn't plug it into the area formula. I plugged it straight onto the graph. That would have become root 5. That would have become 10. So 10 root 5b. Okay, so scrolling up 37, I've now gone through. This one, 35. That could have gone really wrong if you'd expanded that out and tried to equate them. So keep things factorized because things might cancel, and they're going to, in the ESAT, they're going to make the numbers really easy for you. So keep things factorized, and things might work out in your favor. So taking out the x squared, so fully factorizing them, setting them equal to each other, moving that across, and then fully factorizing to get x plus 3. That's a double root. So there's x equals 4, x equals minus 3, 2 solutions. That's how to do that one. 33, I think I explained that one quite well as I was going. If in doubt, as I was in this case, writing out the first few terms of the series is really helpful to get a sense of what's happening. And this is a really common trick, by the way. The fact that the a over 1 minus r is given as 8 over 5, that's especially helpful, for instance, if you have a sum not to infinity. So sometimes they can give you like the sum not to infinity is a 1 minus r to the n all over 1 minus r. It's spotting that that is the sum to infinity. So that can be a helpful trick there. And I employed that here to make my life a lot easier to get the r. And then from there, you can get the a relatively quickly and then sum them up. But I think it's just spotting that trick, because if I'd expanded that out and had to solve like the full quadratic, it would have taken me a lot of extra time. And that already took me too long. Let me check exactly how long this one took me. So going up here, so the first one I did, I skipped that one, then 37. This took 126, which I was fine if I'd actually got it right. I should have spent longer on that. In fact, it really should have been second pass when I had more time. I didn't really have time though. I don't know. That one got me. So 128 on this one. Yeah, this already took 2 minutes. And then 31, I'm so annoyed about this one because I had all the right steps, but just got it wrong. So it's comparing these two. So I was totally right that 0.5 is less than cos pi over 6, but cos pi over 6 would have been root 3 over 2. But 0.5 is less than pi over 6, so it's to the left, so it's moved up the curve. Whereas sine, this would have been root 3 over 2 for pi over 6. But because it's less, it would have moved down the curve. So it's actually the other way around. That is the case. That is the case. And the cos of 0.5 was bigger. That's an annoying execution error. I was right there. But I think because it was taking me 2 minutes 27, I think I rushed it. This is pretty self-explanatory. I don't think I need to say anything more about that. I got it done in 47 seconds. This one is 1 minute 11. They love the 30, 60, 90, that 1, 2, root 3. And so having it primed and ready for whenever it comes up is super helpful. From there, that's 60, that's 60. So it's 120, which is a third of the circle. That was easy. The triangle. So whenever you're in coordinate geometry, it's often easier, rather than doing like half AB sine C, it's easier here to do half base times height, where the base is 2 root 3 and the height is 1. And then that all just came out. So using those skills, that was doable very quickly. So again, if this was in 47 seconds, this one I got done in 1 minute 10. So then this one for 25, that was done in 50 seconds. I spotted quite quickly that was going to have one solution. Run the discriminant on this to show yourself that it has 2 solutions. Because here b squared minus 4ac is bigger than 0. So 2 solutions on that, 1 solution on that. Nothing too taxing. This is 23 is good, but only if you spot that trick. Because if you actually did the full expansion of n plus 1 and the full expansion of the sum of n minus 1, it would have taken you forever. So thinking about the fact that everything is going to cancel apart from un and un plus 1 makes that a walk in the park, which I got done in 58 seconds. Yeah. And then 21, I just took the time to make sure I was expanding it out correctly. But then from there, differentiating wasn't too bad. And then just spending a little bit of time making sure that I was doing a half to the -2 correctly by flipping it to 2 squared and then making it 4. Which I got done in 110. And then I came back and did this in 135. I didn't have a huge amount of time, but I got it done in time. So one conceptual error, because that just got me, the roots one. That's a shame. That was a tricky question. And then one really annoying one on that trig. Cool. So let me move on now to the physics to wrap up. I'm trying to remember what that the error was in the first one. The first one was I made it execute. So it's a couple of execution errors I've made, and one conceptual error. I'm not making the same exam technique issues though, so at least that's good. Okay, so in this one, let me just regain. So how am I not going to make I'm just too tired, to be honest. I'm going to reset. We got half an hour on the clock. Let's go. So 40. No, this is going to take time. This is also going to take time. I like this. So for 38, so it contains that much water at that, 20 grams that. Final temperature. So the energy lost by the water, which is M times C times 25 minus T, the energy lost by that water is equal to the energy to melt the ice plus the MC delta T from T to 0 to get it up to the same temperature T. Okay, so that times that is 7 to... No, what I'm going to do is I'm going to cancel the 20 from all sides, make that 9. So that's 9 into 100 minus 4t is equal to 300 plus 4t. So 900 minus 36t is 304t. Cancel that down for 600, equaling 40t. Cancel the zeros, t is equal to 15, which is d. Okay. So here, 37. So x goes to r, y goes to r. Sorry, y goes to s. Lines. Equal numbers. Okay, so that x to y to r to s is in a 1 to 1 to 1 to 1 ratio. Okay, so after 40 years, that's 4 half-lives of x, which means there's 1 over 16 left, and the remaining 15/16 of x have gone into r. So 15/16, so that becomes 31 over 16. After 2 half-lives of y, there is a quarter left, and the remaining 3 quarters have gone into s. So then the r to s ratio, let's quadruple this to make it 28 to 16. So then r over f is going to be 31 over 28, which is c. Okay. So 36. Scatter mass is centering vertically downwards. Has that speed. Further distance of 20. Increase to that. Okay, so u is 5, v is 10, s is 20. The acceleration, so v squared equals u squared plus 2as, making that 40. So 75 is 40a. So A is 75 over 40, cancel a 5 to make that 15 over 8. So then resultant force is MA. So the resultant force is 150 by multiplying that by 80, which is the 800 minus the drag force. So the drag force must have been 650, which is B. Hold on, let me just make sure you all can see this. Good. Okay. So then moving on with a split time. So 35. Heat is transferred at a constant rate, delta T with time. Gradient is K. Specific heat capacity. All right, so energy is power times time. That energy is going into raising the heat. So MC delta T equals PT. So delta T is P over MC times T. Specific heat capacity then. So that P over MC is equal to the gradient K. So C is equal to P over MK, which is P over MKD. Locking that in. So 34, a high-speed railway line, 60 kilometers apart. Stops at both cities. Maximum speed. So for stage 1, so 120 over 1.5. Let's double it up. Over 3 is equal to 80. So it takes 80 seconds for the first phase of that. And then when braking, it takes a uniform rate. So it takes 60 seconds to decelerate. So that's 80, and then that's a further 60. 60 kilometers, so 60,000. This is taking too long. Whatever. So 0, 120. So that is time t. That is on the bottom time t plus 140. So the average of the two is t plus 70 times a height of 120. That area is equal to 60,000. Knock that off. That becomes 5. So t is 430 seconds, which is C. Lap time. Probably should have skipped that one, but whatever. So microwaves use the camera. Higher frequency is not going to be red, so 1 is wrong. F equals C over lambda. So it's 3 times 10 to the 8 over the wavelength of 1. Well, 12 times 10 to the minus 2. That and that makes 4. So it's a quarter, which is 0.25 times 10 to the 10, which is 2.5 times 10 to the 11. So it's not 2. Wait, no. No, I've done that wrong. So it is 2. So 2 is correct. And infrared, so 3 times 10 to the 8 all over 2.5 times 10 to the 15. Let's double this up to make it 6 and 5. So it's 1.2 times 10 to the minus 7. So it's 120 nanometers, which is UV. So that's not infrared. I think it's 2 only, and I think that's C. Okay, so place from north to south direction, so it's 90 degrees to the magnetic field. Wire carries a constant current. Okay, so for 32, I know that F equals BIL. So it's B interesting. Okay, in north to south direction, so it's 90. So what's happening is place in north-south direction. I think that means that the force is equal to the weight, which is that times 10, times I times a length of 0.4. So it's 0.24 I. So I is 18 over 24, which is 3/4, which is 0.75. So it's either G or H. So the magnetic field is west to east. The current, the field force has to come out towards me, so the current has to go from north to south. So the answer is G. Not confident on that though. Also not afraid to fail in public, so it's fine. At least it'll convince you if it is actually easy or hard. So 6 volts is connected to an 8 ohm resistor. Filament lamp. Reading on the ammeter is that. Okay, so what does that mean? So 0.25. So the voltage on that is 2. So the voltage on that is 4. So, and that's a 2 to 4, 2 to 4, meaning it's got to have double. So the lamp has 16 ohms resistance. And 4 volts at 0.25 amps. So at 0.25, it is 4. So it's not A or C or D or F. So it's either B or E. And I know that as current increases, temperature increases. As temperature increases, resistance increases. V equals IR. So the gradient increases. So that makes it B. Okay, 30. Traveling in the opposite direction. So the horizontal ship of this speed is 8. Speed of the wave is 3, traveling in opposite directions. So the relative speed, if from the ship's perspective, the wave is coming at it at 11 meters per second. And V equals F lambda. So lambda equals 11, equals, we've got time period. So lambda equals V times T. So 11 times 8 is 88. It's the wavelength of the wave, which is H. $29. So training accelerates from rest. Constant, there's a friction force, 1.8 times 10 to the 7. Momentum changes with time. Well, I know that resultant force is rate of change of momentum. So the resultant force is so it's so 12 over 4, so it's going to be 3 times 10 to the 6. And I know there is a resistive force of 18 times 10 to the 6 backwards. So therefore, this must be 21 times 10 to the 6, or 2.1 times 10 to the 7, which is E, because that is the force through the motors. Yes. E, perfect. Okay, take a split. 28. DC constant voltage. Power transferred by all the lamps is that. When a lamp fails, the lamp becomes short-circuited and has zero resistance. What is the new total power transferred to the remaining 19 lamps? Connected in series. Okay, so what's going to happen is originally the voltage is going to be the same. Let's call this 20R. And then if it short circuits and it just goes straight through 0, then it will situation that where that becomes 19R for the same voltage transferred by the remaining 19 lamps. So here I is equal to V over R total. Here I is equal to V over R total. And the power transferred by it's going to be V, power is that times V. So this is, take the old power, multiply by 20, divide by 19, and you get the new power, which is D. Okay, so 27. Uncompressed length of that. So the we know well what we can say. Okay, I'm debating whether to go via forces or whether to say that mgh goes into the. I think the energy stored due to the compression is just the. Okay, fine. Let's do forces. So the weight acting down is 5 newtons. So 5 newtons equals K times the extension of 0.02. So 500 is K is 2K, so K is 250. So energy is a half times K times X squared, which is 4 times 10 to the minus 4. No, let me not do it that way. So 250 times 0.01 times 0.02, 2.5, 1, make that 5, so 0.05 joules is C. Okay. It probably was a faster way. I just wanted to go a safe way because my brain is just not on form this morning. Okay. 6 neutrons more than that nuclide. 6 neutrons more. So they're both X. So that mass number, so 3x minus 7 is 2x plus 3 plus 6 is 2x plus 9. So x is equal to 16. Okay. How many neutrons does that contain? Well, the mass number minus the atomic number is 2x plus 1, which is 33, which is F. Uh, 25. Star is moving away from a space telescope position above the Earth. So if it's moving away, it's going to be redshifted. Emits light like that. The light travels towards the space until it's detected. The frequency, wavelength, and the speed detected by the telescope. So the telescope is going to be redshifted, so it means that the wavelength is going to be larger, and the frequency is going to be smaller. So the frequency is going to be smaller, the wavelength is going to be larger, and the speed is going to be equal to C, so the answer is going to be G. Okay, so 24. Towing a caravan of mass 1,000. Let me just draw it out. 1,400 is towing a thing of mass 1,000. The driving force of the engine at constant speed. So initially, there are resistive forces, and there's a driving force F. Increased by, so that's the resultant force. Okay, so that's increased by 3,000. So we've got an extra 3,000 going to the forward, and an extra 600 resisting, which means there's a resultant force of 2,400 newtons, equaling 2,400 A. So the acceleration is just A, which is 1. So it's a non-ideal transformer, so that's going to affect the currents but not the voltages. So primary, secondary, NVI, I'm just going to end power, NVIP, just so I know what's happening. And again, this is for 23. So there's 100 turns on the primary and 25 turns on the secondary. It is provided with 3,000 at a current of 12.5. Well, P equals IV. I'm going to double everything up. Going to multiply by 4. Knock 2 zeros off. So voltage here is 240. And this is going to step down. So it's a quarter of that, which is 60. The current in the output coil is 440, which means that the power is 2,400. So the efficiency is 2,400 over 3,000, which is divided by 6. Oh, I nearly got that wrong mentally. Really am not informed today. So it's 80% efficient, which is F. Okay, so 22. I've got time though, so it's fine. Phyiscs moves, so the pressure is increased by 20%. Density. Well, density is mass over volume. So volume is mass over density. We know that PV equals constant, so P1V1 equals P2V2. So P1, the same mass is going to be the same, over rho 1 equals P2 mass over rho 2. And I'm going to rearrange, I'm going to rearrange this. So P1 over P2, M's cancel, equals rho 1 over rho 2. The pressure has increased by 20%. So P2 is 6/5 of P1. So that cancels. So that becomes 5 over 6, which is rho 1 over rho 2. So the new density, rho 2, is 6/5 of rho 1, which is 1.2 rho 1, which is E. There was a faster way that I'll explain later. But I've got time, so I went the simple way. A resistor has constant voltage of 9, total charge of that in 4 minutes. What's the power dissipated? Well, current is charge in unit time. Cancels for 3 is 0.75 amps. And power is IV, which is 27 over 4, because that's 3/4, which is 6.75, which is B. Okay. So I'm now going to go back to the beginning where I know I skipped a couple questions. Not that one. I'll do 39 first. Because I know with my brain, I can't handle speeds very well. So I'm just going to leave anything with speed to the end. That's density and that density. So what that means is 64 grams of X and 100 grams of Y are poured into a cylindrical container, allowed to settle. They don't mix or react. Base of the container rests on a horizontal surface. What is the pressure due to the liquids? Okay, I'm going to draw this out because 4 centimeters above the interior of the base of the container. So what that means is that there are 4 centimeters of X and it's lower density, so it's floating on top of 5 centimeters of Y. And the pressure at a height of 4 centimeters above the base, at this point, the pressure is rho GH for the different things. So, or rather, let's just take mass over come on, brain. Lock in. So 64 grams. So that has that's 0.064 kilograms, which has a weight of 0.64 newtons, all over a cross-sectional area of 20 times 10 to the minus 4, which is 2 times 10 to the minus 3. So it's 0.32 times 1,000 is 320 pascals from X. Y, there's 20 grams above here, which is 0.2 kilograms. I should have just put this together. All over again. 0.02, so 0.2 newtons over 20 times 10 to the minus 3, over 2 times 10 to the minus 3, because it was 20 times 10 to the minus 4. So it's 0.1 times 100 times 1,000, which is 100 pascals from the amount of Y. So in total, it's 420 pascals, which is G. God damn it. Okay. Okay, so now we're going to go and do 40. Pulse of ultrasound. So partially affected, but there's a crack. What is the distance between the crack and the far end of the rod? So I'm going to call that X. So I know, and that full thing is L, that times T2 is bigger. The distance, okay. I know that distance, so it goes there and back, and it's this one here, if the full is L, so this is traveling L minus X. So that total distance is equal to the speed, which is the same, times T1. I also know that 2L is equal to V times T2. So 2L minus 2X is equal to VT1, which means that VT2 minus 2X equals VT1. V into T2 minus T1 equals 2X. So V into T2 minus T1 all over 2 is equal to X. We don't have, we don't have V. So from here, but we do have L. So here I know that V is equal to 2L over T2. And I'm going to stick that in. So 2L over T2 into T2 minus T1 all over 2. The 2's are going to cancel, and you're going to get L into T2 minus T1 all over T2, which is E. I think I've got a minute and a half left. I think that's all the questions now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 answers submitted. I've got a minute left. I'm going to call it there. Now this is important. My brain is just, don't know. I'm not locked in. I think I didn't sleep very well. I haven't had breakfast yet as well. So my brain is not on top form. And I think what you can get from this is like how to handle it if you, let's say you have a morning exam, because I know the ESAT, like getting an ESAT center was like getting Taylor Swift tickets. So it's really possible that you've been forced to take a time slot that isn't best for your brain. I'm clearly working in a spot where my brain is not warmed up yet at 100%, not locked in, kind of pulled back from it. You might find yourself in that situation. So what do? You'll notice that I recognized the state that my brain was in, and that affected the choices that I made during the test. So places where I could have taken a shorter route that required me to put more thought in. I just went, no, my brain isn't going to do that. Let me take a slightly longer route where I'm just going to be safer. Let's see how much that actually worked. So going to the answers, 38 was D, 37C, 36B, 35D, 34E. Nope, not that one. Okay, so let's see what I did wrong there. Train stops in both cities. Okay, so why don't okay, let's redo this a different way. So I know, let's see that for both of these. So 1.5 starts from 0, goes to 120. Let's work out about SNT. Well, hold on. Now this should have worked. So 100. So V equals U plus AT, certainly. So 120 is 0 plus 1.5 T. Let's double it all up. So T is equal to 80 seconds, certainly. So it takes 80 seconds for the acceleration. It takes 60 seconds for the deceleration. And then it spends time T in the middle. And that distance has to equal 60,000. This should have worked. Oh my God, I'm so stupid. That was T. I just didn't follow it through. That was exam technique, pure and simple. It is true that T is equal to 430, but that's not what I wanted. I wanted T plus 140. And they didn't trick me, but they anticipated the trap. So the answer was E. That's really frustrating. Okay. So I got that one wrong. 33C, 32G, 31B, 30H, 29E, 28D, 27C, 26F, 25G, 24A, 23F, 22E, 21B, 39G, 40E. Okay, so one mistake there. That was really silly. That was just me not paying attention to what the question wanted. So all in all, through the entire run, same number of answers I got wrong as last time, 4, but this time there was one conceptual, there were 2 executions, and 1 little exam technique. And so I think, well, actually, I'll do let's go through specifically physics, and then I'll do the full recap at the end. Go into the top. Okay, let's see what the situation was. Is there anything I need to explain further? So 38, I think that was pretty self-explanatory. The energy lost by the water equals the energy gained by the ice. ML plus MC delta T. Look at how I cancel. and how I group things. So I thought of making that 720, but I realized like that's going to make my life a lot harder. Instead, I just divided both sides by 20 to make that 9 straight away, and multiplied the 4 in to make that 100. You see, I did that a lot actually, where it was a 0.5 or a 50 or a 25. Scaling it, that was because I couldn't be bothered to divide by 50 or by 25. My brain wasn't in the mood for that, so I was just doubling up to make it 100, and then I could divide through quite consistently that way. So that's going to be 9 multiply the 4 in. So then having divided by 20, it's 300 plus 4t. Expand that out. Yeah, this was fine. This I quite liked. I'm going to go through this in a bit more detail because this happens quite a lot. So they gave us the initial ratio. We know that it reduces by a half every half-life. So after 4 half-lives, it's gone to a half, quarter, eighth, 16th. And the remaining 15/16ths have turned into R. Same thing for Y. It's gone to a quarter, and the remaining 3/4 went into S. By scaling them up, we know the R to S ratio is now 31/28, which is what they were looking for. And I think that idea of using ratios when you've got things combined and different things turning into other things is quite a helpful technique here. 36. Yeah, get the acceleration and therefore get the resultant force. Weight down, drag up. I don't think that was too controversial. I think this was pretty self-explanatory as well. MC delta t equals pt. Rearrange it into the form y equals mx plus c. And then set that to the gradient k and rearrange for c. Not too bad. 34, we talked about. I just needed to actually calculate the right quantity. Remember 33, which I didn't mark down. That was here. Okay, so it is definitely the case that as the frequency increases, you're going to move towards blue. So 1 was just wrong. I calculated through to work out that 2 was correct. And then I calculated the wavelength of that frequency of light. And if blue is 400, that is ultraviolet, which is not the infrared used for thermal imaging. So that's why it was 2 only. This is F equals BIL, which is the new equation that a lot of you haven't learned yet. So that's one part of the spec. Have a close look. Make sure you're very comfortable there. I wasn't quite seeing the situation, so I was like, all right, if the resultant force is 0, that probably means it's counteracting the weight. So weight down, force from the magnetism up. So that's where I got the weight being the 0 point, well, the mass times 10, put that in for the force. Field 0.6, length 0.4, rearrange for the current. And from there, I used my left-hand rule to get the direction. So hopefully you followed that as I was solving it. This, I did a lot of that like in my head because I knew that drawing the diagram was going to take me a lot of time and the calculations were quite simple. So I thought, okay, this is going to be something I can do. So I times R gave me 2 volts on there, gave me 4 volts on there, which made me go between B and E. And from there, I used the logic. Current goes up, temperature goes up, resistance goes up. On a VI graph, V equals IR, so R represents the gradient. So if R goes up, gradient goes up, and the answer is B. That was pretty good. This, relative speed, time period. Maybe think it through a bit slowly, but it definitely works, what I did. This, I think, was pretty self-explanatory as well. Resultant force, rate of change of momentum. Plug that in. So the resultant force is 3 times 10 to the 6. So I made everything in terms of 10 to the 6 to make sure I didn't get it wrong. So there's 18 resisting, then there must be 21 driving. This, I think I explained quite well. This, I just want to go back and check if I could have done that from energy. Because what happens is the center of mass, I want to see if mg delta h would have worked. So mg delta h 0.2, 0.1. That would have been D. No, that would have been wrong. Interesting. Interesting. That wouldn't have worked. Because as I was thinking, I was like, does some of it go into internal energy somehow? Okay, so I'm really glad I went via forces. Why is that the case? I suppose. Oh, okay, I think I can see what's happening here. I'm wondering if it's because of that factor of a half. So this is the energy versus extension, but I think we calculated if by doing the change in GP of the sphere, um, we would have calculated the full energy, but only half of that is stored. Is that right? No, I'm thinking of capacitors. All right, I'm not there right now in the state of mind to find the explanation quickly. I'll have a think about that one. But I knew that that was the more conceptual route. That was the route that made me think a bit more. And as you can tell, today is not the day. So, like, if this is you on the day, find the safe route and just do it. Like, I knew this would be a little bit longer, but I knew I could do it, so I just did, and it worked. And I think that's the lesson. Just don't overcomplicate it. Just do what you got to do. So 26. That was just math. That was fine. I think you all followed along on that. I think you all also follow along on 2F. This is simple redshift, which means that the frequency goes down, the wavelength goes up, but the speed of light is the speed of light. I think you know this. 24. Okay, so this was a bit more complicated. The diagram did help me. I was going to do before and after, but that would have taken too much time. So initially, I was thinking the resultant force was going to be 3,000, but then there's an extra 600 resistive force, which means you got that 2,400 newtons of resultant force, giving acceleration to 2,400 kilograms in total. So A is just clearly 1. 23. I like this. This is how I do transformers. Primary, secondary, list all of the information, and that way I never ever get confused. So the turns were given to us, power was given to us. You were able to work out voltage, which means you were able to work out this voltage. And from there, you could work out the power, and then you could take the ratio to get the efficiency. Cool. Here, okay, I said there was a faster way. If you know from your gas laws, if you know the kinetic theory, you know that pressure is proportional to density. So just straight up, as soon as the pressure increases by 20%, the density increases by 20% at the end. So this really I could have done in 10 seconds, but I wanted to show how you would do it if you weren't really confident on that syllabus point. And in fact, we kind of demonstrated that here. So if PV equals constant, that means that PM over rho equals constant, which means that P is equal to a constant times the density, which means that it's proportional to density. So that's how you can argue that. If you learn that result, clearly it can save you a lot of time. And this, self-explanatory. 39. My brain wasn't good enough to do rho GH, so I had to do it from first principles, and it worked. I think one thing I did quite well was drawing it out and understanding what the heights would be for what we were looking at. The fact that we were looking at being underneath 4 centimeters of X and 1 centimeter of Y. What I really should have done probably is combined them to get the total mass above. So the total mass was going to be the 64 grams of X and 20 grams of the Y. So it was 84 grams in total. Multiply that by 10, divide that by 2 times 10 to the minus 3, and you quickly get to 42. .42 times 1,000, which is your 420. So that would have been faster if I'd got the total mass. but that was how they wanted you to do that. I don't think rho-GH would have done us any favors because the density changes on the transition between X and Y, which is, I think, why they set the question that way. And 40, it's just remembering to double the distance and just be really diligent. Okay, so I think that explains all of the paper. Right, I'm going to summarize. Let's stop sharing screen. So I think the main thing to take away from that is clearly my brain was just not at 100%. But I was still able to get the vast majority of marks using good technique and being very aware that the state my brain was in. So not taking unnecessary risks, just going for the really safe path. And I think that's something you can take on board as well. Optimize, like, self-awareness is so important. If you're really gunning for it, know that, and you can really, like, it affects your strategy. And that's something you can practice. I think it's important practicing. If you know, for instance, well, I mean, you know, you've signed up for the paper, so you know exactly what time of day it is. So clearly, last Thursday when I was doing it in the afternoon, I'd warmed up into the day a bit more. I'd had some like breakfast in me. My brain was just a lot more alert, and so I was performing a lot better. This time, sort of woke up, didn't really do much, went straight in, did this, no breakfast. My brain isn't operating in the same capacity. What you can do, you know exactly what time you've booked your paper. If you're doing your practices, do them at that time of day. So your body goes, okay, if you have a 10 a.m. paper, you go, right, 10 a.m. is go time. And practice it, like, so clearly I need to have breakfast before I do one of these, or else my brain is not going to be on good form. I need to have good sleep before I do one of these, or else I'm not going to get my best workout. And so by practicing getting yourself ready at the exact time of day you're going to do the paper, I think you're going to know that you've got yourself ready to perform your best work. So that's one thing I've definitely taken away from this. But it's also diagnostic. So I know that when I am stressed, when I am tired, when I am hungry, what are the mistakes I make? So there was one question where I just didn't follow through all the way to the end of the question. I skipped a few steps in the math, but mainly I was making these execution errors. I'm trying to remember what they were in the math and math 1 and math 2. Math 2 was not good for me. Where was it? Where was the question? Oh, that was, yeah. Okay, so this was this required a lot of brain lift. Oh, you can't even see what I'm sharing. The one with the I'll reshare actually. It'll be worth it. So this one here required a lot of mental load. So I was balancing a lot in my head at once. It's sort of the moment where your computer the fan would start going because you're asking a lot of it. Here, my brain was worrying, and I should have clocked that my brain wasn't in the right state for that, and that's where I was really likely to make an error. What I should have done is slow down and just made sure absolutely certain to plant that, because I had all the right ideas but just didn't assemble it correctly. And then here, yeah, again, that was another one where that required a lot of mental lift, and my brain clearly wasn't there. So that's letting me know, like, the high-end processing power dips when I don't have enough sleep and I don't have enough food in my system. So that informs how I prepare for, like, the real thing. Make sure I've slept well, make sure I've eaten well. And I don't think there's much besides that, because I think if I was in a better state, I would have gotten both of those correct. So I don't think there's anything I need to do in my, like, to practice skills. I think those skills were there. It's just about making sure I'm good and ready whenever I set a paper. And that's the kind of post-game analysis you can do on yourself to really get the most of every past paper and think, do I know exactly what I need to do to maximize my score on the day? Do I know my exact strategy, not just in terms of what happens when I hit the desk, in terms of doing multiple passes, making sure I'm answering the right questions in the right order, getting that confidence, getting that momentum, doing the right things. But even before you hit the desk, in terms of your preparation, making sure you get there in enough time that you're not stressed, making sure you are hydrated enough that you can think, but not so hydrated that you need the bathroom and get worried about that. All of those things around the paper can influence your performance on the day. And so using your past papers to optimize that part of the process, not just the process in the paper itself, is something you can be thinking about. especially with 1 week to go until the actual ESAT, like it is right now. So hopefully that's given you a good amount to think about. I'll make sure to get this sent round. So a lot of you are looking at this. We'll chat about it. We'll see what you want to see more of from me. And I can sort of provide that to help you in these final stages before the paper. But right, I think that's about it for today. Work hard, have fun. I'll see you next time.